Okay, so as you probably noticed, we're going to be skipping over lesson 9. In order to do lesson 9, we would have to do equations where you had a variable on both sides of the equation, and really don't want to do that if we're not going to be in the room. So lesson 10 is a lot simpler. We have a new formula that we're going to be using. We'll talk about it really quickly and then get into the problems. This is not a very long lesson. So hopefully we'll get done with this pretty quickly. Um, the formula we're looking at is for interest. That's what the whole lesson's about, is simple interest, meaning interest you earn at a bank, interest that you earn when you take money out of the bank when you use a credit card. So this is simple interest, and if we were in class, we would probably do compound interest, but over the videos, it's going to be a lot more difficult to do it that way. So anyway, so interest, I, is what is going to be represented in the formula. Principal is the amount of money you have in the bank, how much money you start with. So that is your principal. And the R, the rate, is what is the percentage rate you are going to get at a bank. Usually this is in the single digits, 2, 3, 4%. And then the time, how long you're going to keep it in the bank. Now, for the purposes of our math problems, the rates usually be measured in years. That's usually how they're going to compute the interest. Although, if you had an actual bank account, the interest is computed monthly. Okay? All right, so time is pretty obvious, so not much we need to go over here other than going to the first problem. So it says Larry invests $100 in a savings plan. Okay. The plan pays 4.5% interest each year on his $100 account balance. How much money will Larry earn in interest after 3 years and then after 5 years? So 2 problems here. Nothing very difficult. You're going to use the formula up above. And just remember, the question here is asking you for how much interest that he earned, not how much money he had in his bank account or what was the balance after 3 years. So all it's looking for is for you to find the interest. So go ahead and I guess we set that problem up and then we will continue. Okay, so for the interest and time, I did both formulas for both 3 years and 5 years. So if you haven't already done that, do pause it again and do your substitutions for 5 years. And they're basically the same thing. Only difference would be the time. So the amount that he has in the account is still going to be $100. The rate is 4.5%. The only thing that's going to change is the time. Okay, so this is for 3 years, so the principal is $100. The rate is 4.5%. I changed it to a decimal. If you want to keep it as a fraction, that's fine, but in the end, you'll have to change everything to a fraction if you want to leave it like that, and then multiply it by 3, which is the time. And then for 5, it's the exact same thing, except you're multiplying it by 5 instead of 3. Right, so here it's just simple multiplication, and remember, as usual, you cannot multiply by a percentage. You have to change it first into a decimal and then do your multiplication. All right, so continue this when you have an answer for both these problems. Okay, so because these two formulas are exactly the same, the first 2 parts, it makes sense to multiply 100 times 4.5% first, as I did over here, and then just multiply it by 3, and then multiply it by 5 separately, because the answer is going to be the same. Here, 100 times 4.5% is the same as here, 100 times 4.5%. So if you multiplied by 3 first or 5 first, then obviously you would have 2 different numbers. But anyway, you should get $4.50, which is basically the interest that you would get for 1 year. And then you just multiply it by 3 here, you get $13.50. And for 5 years, you would get $22.50. Okay? So pretty straightforward there. Okay, so it says, how can you find the balance of Larry's account at the end of 5 years? Well, you could do two different ways, just like before, um, because we already multiplied it by 5 years. We found out how much interest we're going to get in 5 years, which was our $22.50. We could simply add it to $100, and that would get us the amount for 5 years. Or something that you might want to get used to doing. We did these in the previous problems. So I just means interest. And if we're trying to find the balance now, we're not just trying to find how much the interest is. So if I take $100 and I multiplied it by, let's say, 5%, so 0.05, you're going to get $5. But that's not the balance. This is just the interest right here. So it's $5 of interest. If you wanted to figure out what the balance was, you would then have to add the $5 to the principal, which was $100, and get $105. Now, your alternative to that, just like we did with the markup problems, is to add 100% to it. So that basically means that instead of multiplying it by 5%, you're going to multiply it by 105%. Because if I multiply it by 1.05, and here I'll just kind of do it over here really quickly. We have two decimal places. We get the correct answer, which is $105. So by multiplying it not by 5%, 5% is if you want to find the interest. So I take $100, I multiply it by 5%, I get $5. That's the interest. If I just want to skip the intermediate step, meaning I just want to figure out what the balance is, then you would multiply it by 105%, because we're including the base cost, meaning or the principal. So if I multiply this by 100%, I would get $100. 100% of $100 is 100. If I multiply it by 100 plus another 5% or 105%, then I would get the balance plus the interest, which is what I got here, which is $105. This is something you'll need to use when they give you the balance and you want to work your way back to the original amount, meaning the principal before the interest was added, which I'm not sure if it's coming in this lesson. It might be in the lesson after this one. Okay, so this is the first exercise. It says find the balance of a savings account at the end of 10 years if the interest rate each year is 7.5%. The principal is $500. Okay, so go ahead and use the formula, do your substitutions, and work it out. So you're looking for the balance, not the amount of interest. So two different ways to do this. I'll do them both ways so you can see both. Okay, so all you really had to do is a simple substitution. So the principal here was $500. The rate is 7.5%, and the time was 10 years. The interest rate is paid every year, so we multiply it by 10. So because it's all multiplication, you could do it in any order that you want, and it would make sense to me to just get rid of 10 times 500 and end up with 5,000 times 7.5%, which ends up being $375, which you then add to the original principal, which is $500, and that'll get you a total of $875. Okay, so let's move on to the next problem. That. All right, so example 2, this one is a little different because it's dealing with a time period that's not 1 year or a number of years. So let's see what it means in a second. It says a $1,000 savings bond earns simple interest at a rate of 3% each year. The interest is paid at the end of every month, which is important for the next part. How much interest will the bond have earned after 3 months? So the 3% is after a year. Now, if the interest was only paid every year, then you would have no interest whatsoever. But because they tell you the interest is paid at the end of every month, which is kind of normal for banks to pay interest, even if it's a yearly rate, is to pay it monthly. So we have 3% for the year, but we obviously can't multiply this by 3 because multiplying by 3 would be for 3 years. So what should you think we should write for this? So if it was 1 year, we would multiply it by 1, or basically the principal is 1,000. The rate is 3%. That's pretty obvious. So the only difficulty here is, what are you going to write for the months? How are you going to represent that? Again, if it was 1 year, you would multiply it by 1, basically get whatever 1,000 times 3% is. That would be the amount of interest. Okay, so go ahead and write your formula and do your substitutions, and when you're ready, you can continue. Okay, so we're just going to do the setup here, and then if you didn't get it correctly, then you can make the corrections and do the work. All right, so the issue is 3 months. And since it's paid monthly, you got to figure out what is the rate that you're going to, of interest you're going to get for 3 months as opposed to the year. Now, what you could do, if you wanted to, is divide the rate by 12 months, but then you're going to end up with a really small percentage, which is a possibility. Or, which is what I did, is I wrote it as a fraction. So 1,003%, that's all right there for the rate and the principal, but for time, I wrote it as 3/12, because 3 months is 3/12 of a year. So if that's 3/12 of a year, if I multiply the interest I would get, meaning 1,000 times 3%, which would be my interest for the year, if I multiply that by 3/12, I should then get what my interest would be for the 3 months, not for the year. Okay, so go ahead and complete that and then continue. Okay, so I'm just doing the multiplication. So 3% of 100 would be 3. So 3% of 1,000 is 30. You really didn't even have to do the multiplication for that one. If you remember that 3% per 100, 3% of 100 is 3, so 3% of 1,000 would be 30. And then we multiply that by 3/12, change everything to fraction over there, simplify if you can. Ended up with 15/2, which you then cannot leave. You have to divide that. You get $7.50 or $7.50. Okay. So that would be the amount of interest, and that would make sense. And going back to the problem just really quickly, $30 would be the amount of interest that you would earn for a full year. So 1,000 times 3% is $30. You would earn $30 of interest for 1 year, but we want 3/12 of that. So that's $7.50. So that makes sense with the numbers that we have. Okay, so the next problem has to do with using the formula, but instead of solving for the interest, you're going to be solving for other values, which you probably assumed that was coming at some point. So it says, Mrs. Williams wants to know how long it will take an investment of $450 to earn $200 in interest if the yearly interest rate is 6.5%. paid at the end of the year. So this is an interest that's paid yearly, so you can't do months, it's how many years. All right, so we have the investment. Investment is another name for the principal, in case you're wondering. Principal is how much money you are putting in the account to begin with. And she wants to earn $200 of interest. So set this problem up, do your substitutions, and then resume. Okay, so obviously we are looking for the time. in this problem. So we use the formula just like we had. Interest equals principal times rate times time. The interest is $200. We know what the interest is. We want to find the time. The principal, the investment, is $450, and the rate is 6.5%. So from this, we should be able to use simple algebra and solve for t. So go ahead and do that. When you're finished doing the computations, resume the video. Okay, so there was a little bit of work in this one, especially with dealing with the percentages. So here we did the multiplication. You had to do 450 times 6.5%, which had got you 29.25 times t, or t equals 200. You divide by 29.25 on both sides to isolate the variable, which is t, and you basically get, do your division, you got 6 with a remainder, which means at the least, since this interest is paid yearly, it's going to be 6 plus more, which means you're going to have to at least wait 7 years in order to get the interest you want. So the answer to this problem is 7 years. Okay. All right. So next one, we have a couple exercises. So these you should be able to do on your own, but let's take a look at them. It says, write an equation to find the amount of simple interest earned on a $600 investment after 1.5 years if the semi-annual interest rate is 2%. So semi-annual means every 6 months. So for this one, this is actually a little different than the last few. Write the equation for this. So we have investment of $600, and this is after 1.5 years. And we have a semi-annual rate of 2%. So for this one, you might actually just want to write the equation and substitution first and then resume, like for to make sure you just don't work ahead and you have the wrong numbers put. All right, so resume when you have your formula and substitutions done. Okay, this problem is kind of a little cheap because they really haven't given you any examples like this. So before we begin and go over what is the correct substitutions, when you're writing down the time, you want to write basically how many times that interest rate is going to be paid. So if we have 1.5 years, how many times would a semi-annual rate have been paid? So the semi-annual rate is 2%, but how many times would they have paid that 2% in a 1.5 years? So that would be what you would want to put for the time. You do not want to use 1.5. Okay, because it's a semi-annual rate, not an annual rate. Okay, so this is what would be correct. So we have the principal, which is $600, and 2% is the rate. I don't think anyone got that part incorrect, but the time is 3. And the reason it's 3 is because 1.5 years, well, 1 year is 12 months. And another half a year would be another 6 months. So 1.5 years would be 18 months. How many times would you pay the bank pay a semi-annual interest rate? For if it's a 6-month rate, it would be 3 different times. They're going to pay that 2% 3 times because it's every 3 months. Okay? So again, I know that was kind of a cheap problem, but it actually is a pretty good to pay attention to how often you're going to pay, or the bank is going to pay that interest rate to you, or how often are you going to have to pay that interest rate. So 3 times 3. So from here you could work out the rest and then resume when you're ready. All right. So once again, because the 3 and the 600 are both whole numbers, it's always best, if you can, to avoid putting a decimal in a problem if you can. So I did 3 times 6 first and got 1,800, then multiplied it by the 2%, which did over there, and got $36. So $36 would be the amount of interest. Okay, take a look at question number 3. So it says, A $1,500 loan has an annual rate of 4.25% on the amount borrowed. How much time has elapsed if the interest is now $127.50? Okay, so once again, this is a slightly different problem. I'll let you go ahead and try solving this without interruptions, and then when you have your final answer, resume the problem. Okay, so once again, we are looking for the time. We have all the other information. The loan is the principal. So in this case, it's a loan. That's the amount that you are borrowing, or a person borrowed. So that's the original amount of $1,500. The rate is 4.25, which you can use as a fraction, 4 1/4, or 4.25 is perfectly okay as well. And then we have the interest. The interest is $127.50. So the setup should look something like this. So interest equals principal times rate times time. The interest is $127.50. The principal is $1,500, and the rate is 4.25% times t. So we multiply 4.25 times 1,500, and you should get 63.75 times t. Divide 63.75 on both sides, and then the answer from that part is obviously 2. So t is 2, which is the years it would take to earn that much interest. Okay, so I believe that is the last of the problems. And most of these problems are basically the same. You just use the formula that you're given, do the substitutions. Number 3 has a couple different variables, so make sure you read the questions carefully and that you are including the work with it. You do not need to do the challenge problem, so you do not need to do number 4. So 1, 2, and 3. So a short lesson and a short assignment. Okay, so just do 1, 2, and 3. Make sure you're showing your work. And for the graphing part, you can also skip that for number 3. Don't worry yourself about that, right? So any questions, leave it below. Otherwise, lesson 11 on Friday.